Hello and welcome to today's presentation, Disinfection Dysfunction, Avoiding Common Cleaning and Disinfection Mistakes. Today's webinar is being presented by Lighthouse Life Sciences and Virox Technologies, makers of PeroxyGuard disinfectants. You will have the opportunity to submit your questions today by typing them in the chat section located on the right-hand side of your screen. There will be a live Q&A at the end of this presentation, but submit your questions at any time. So without any further ado, let's get started. I would now like to introduce our presenter, Matthew Buccioni, Infection Prevention and Biosecurity Expert. So over to you, Matt.
Thanks, Laura, and thanks everyone for joining in today. So today I'm going to talk about common cleaning and disinfection mistakes, and more importantly, how to avoid these common mistakes and implement cleaning and disinfection protocols that are preventing both animals and people from infection. And as Laura said, we definitely encourage you to, if you have questions or comments at any time throughout the presentation, definitely don't hesitate to throw those in the chat, and we will get to everything at the end of the presentation. So with that, we'll get started. So I think before we jump into what these mistakes are for cleaning and disinfection, I think it's important to set the stage a little bit to talk about why it's important that we need to disinfect in the first place. And so I think the first 2 points here are a little bit more obvious. So we want to prevent illness and death in animals by killing pathogens that can cause disease. And we also want to protect the health and safety of team members, so staff who, by killing pathogens that can cause infections in humans as well. But the next point may be a little bit less obvious, and we want to clean and disinfect to protect the integrity of research results. And I'll explain what this means on the next slide. So this slide shows a diagram of some of the different environmental variables that can interfere with research results. And so you can see that there's quite a range of different factors here. So anything from odors, noise, light, and then of course the one that I highlighted on the bottom is pathogens. And so pathogens can really interfere with research in two main ways. So they can do this in the way that we just talked about, by making animals sick and unfortunately in some cases even causing death in animals. Obviously this interferes with the progress of research projects. But pathogens can also interfere with research even if they don't actually make the animal sick. So even if we're not seeing this clinical disease, signs of disease, pathogens are still capable of infecting animals and maybe influencing the physiology of the animal or influencing the behavior of the animal in some subtle way. And so while it may not be causing sickness or death, you can still get adverse impacts on research projects as a result of pathogens in this way. So how are pathogens being spread in lab animal environments? So we know that one of the main ways that they're getting around is through fomite transmission. And what I mean by this is that pathogens, so we're talking about viruses, bacteria, and fungi, can survive on surfaces, and we call these surfaces fomites. So when we talk about fomites, we're really referring to a surface that can serve as a point of transmission for an infectious pathogen. And then pathogens on these surfaces can be transferred, either directly to animals if they're touching the surface, or even indirectly. And an example of this might be, touching a surface with our hands or potentially even footwear, and then from there spreading the pathogen to the animal. And we know that exposure to these contaminated fomites actually has been linked to disease outbreaks. And so disinfection is really our first line of defense in stopping transmission of pathogens on surfaces. So this brings us to our first mistake that is sometimes made with cleaning and disinfection, and that is failing to read disinfectant labels and safety data sheets. So these two charts tell an interesting story, and these are data from the CDC. And what this is showing is that the CDC was tracking calls made to poison control centers as a result of exposure to products used for cleaning and disinfection. And they looked at it over a few different periods. So the first was from January to March 2018, and then they looked at that same period for 2019 and 2020, just this past year. And as you can see, the blue lines show 2018, 2019. You can see that the The rate of calls is really bumping along at a quite a steady level. Still maybe surprisingly high. I know I was surprised when I saw those baseline numbers, but you can see that when it really takes off is looking at that black line for 2020 when we get into late February and early March. And of course, this makes sense because this really coincides with when the COVID-19 pandemic became really widespread in the US. And we saw this massive increase in the amount of cleaning and disinfection that was taking place. And although it may not be surprising that this trend happened the way it did, it really drives home the fact that cleaning and disinfection can be dangerous if not done properly. And so we know that in a lot of cases, this unsafe exposure is really a result of two different things. First of all, from failing to read product labels and safety data sheets. So that's that important safety information about the product. And then the second is, maybe not necessarily wearing the proper personal protective equipment that's required in order to use the product safely. So in terms of tips for safe disinfection, it really comes down to a couple key things. So the product label and the safety data sheet are really the gold standard resources to consult whenever we're choosing and using a disinfectant safely. Want to make sure that personal protective equipment is always being worn. And whenever possible, selecting and using a safer disinfectant products wherever we can, just to minimize that risk of these adverse events. And so we're going to talk a little bit about, obviously we understand the importance of this, of choosing a safer product, but how do we actually evaluate products to to make sure that what we're using is safe? So I mentioned the label and the safety data sheet, but we're going to get into a little bit more detail about how to actually interpret these resources. So Section 2 of the SDS is going to contain information on the relevant hazards associated with the product. And the system that it uses is called the Globally Harmonized System. This is a standard system that's used certainly in the US and Canada. And it breaks hazards down into three major types. So the first is physical hazards. Then we have our health hazards. And then the last one is environmental hazards. And this hazard class is not always going to be required by OSHA. And so you may see it less frequently compared to the physical hazards and the health hazards. And so the first thing to look for on that SDS and even on the product label is whether there are any hazard pictograms on the product. And you can see I put them all there. And so the top row of these pictograms are physical hazards. So looking for things like, risk of explosion, potential for flammability, compressed gas, possibly looking at corrosivity to surfaces. Whereas the bottom row, we have our health hazards as well as our environmental hazard. Is just the one pictogram on the far right bottom there is our pictogram for environmental hazards. So the first thing to look for is whether there are any hazards here and what these mean in order to make sure that we're understanding the risks associated with using the product. But it doesn't end necessarily with looking for pictograms because not all hazards are necessarily going to require a pictogram. Some hazards might just be written on the product, on the label or the SDS in the form of a hazard statement. And so this is also under Section 2 of the SDS. And an example of what this might look like, for instance, it could say causes mild skin irritation or causes eye irritation. And even if there's not a pictogram on the SDS or on the label, it's still important to look out for these statements as well to understand any necessary risks. So in terms of tips for, once we kind of read this and figure out what's going on, for choosing a disinfectant that's going to be safe for people and animals. So we want to look for a product that's going to be not classified for any of these GHS hazards at the in-use concentration. And the reason that I make the distinction between in-use concentration is because if you get a product that's a concentrate, it may have different safety considerations once you actually dilute the product. So we want to focus on this information for the product that's actually being used as part of your day-to-day operations. And so choosing a product that's non-irritating to animals as well as people, that's going to be non-allergenic and non-sensitizing, and also that's going to be non-hormone disrupting. So this is just a quick snapshot of a safety comparison of some of the disinfecting chemistries that you'll commonly see in the life sciences industry. So it's important to understand anything that might be relevant to the product that you're choosing. For instance, chlorine oxide-based products might be associated with skin irritation or eye irritation, whereas other products like quaternary ammonium compounds, also known as quats, is sort of like the short form, may be safer from a human health aspect, but could be associated with different factors that may make it not ideal for use in lab animal environments. For instance, with quats, we have documented fertility issues in mice as a result of the use of quats. So just understanding the safety profile of the product that you're using and making sure that it's going to be an ideal fit for your facility based on this. So here's just two examples to kind of take what we've been talking about and putting it into practice by looking at two different SDSs for different products. So on the top one is that example of the ideal product that we want to be looking for. So this is the section 2 heading is where we're going to look. And then under classification, we can see that it's not classified under any hazard class, meaning that no specific hazards have been identified that need to be disclosed on the SDS. And you can also see that under label elements, so under the hazard pictograms, there's no pictograms associated with it. And there's also no hazard statements associated with the product. And then that's contrasted with the example on the bottom. And this is an example of a product that does have more safety concerns that we might want to be aware of. So if you can see, I know it's kind of small and I do apologize for that, but under GHS classification, we can see that it is classified for both skin irritation and eye irritation. We can see the hazard pictogram for potential harmful effects to health. And we can see those hazard phrases that are associated with that as well. So this is just kind of an example of what this might actually look like as you're reviewing SDSs and how you can use that to ensure that you're choosing the safest product possible. So really what it comes down to is we want to look for a product that is going to be a balance between efficacy and safety. You know, obviously we need a disinfectant to be effective against pathogens. You know, that's kind of like the baseline, but we want to do this without compromising on safety. So we want a solution that's going to be tough on pathogens without ever compromising safety to people and animals. So that's a really critical thing to look for when choosing a product and using it effectively. So our second mistake is underestimating the importance of cleaning. So first, I think it's important to make the distinction between cleaning and disinfection because these are terms that we kind of hear thrown around a lot, sometimes almost interchangeably. But I just want to make the distinction that cleaning isn't necessarily going to be killing any pathogens. So cleaning is the process of physically removing dirt and debris from a surface. And it may be removing some of the pathogen load from the surface, but we're not necessarily going to be killing any actual organisms. You know, that's really where disinfection comes in. Disinfection is using that product that's really going to be effective at killing the pathogens that we're concerned about. And so just to kind of show an example of what this looks like almost at the microbial level. So we can see on the far left is a plate that was taken from a surface that had not been cleaned, so prior to cleaning. And you can see, you know, quite a fair amount of contamination on there. The middle plate is after having cleaned the surface, but not disinfected it. So you can see we do have quite a reduction in the pathogen or the microbial load just from removing a lot of that dirt and debris from the surface. But as you can see, there's still an unacceptably high level of contamination on the surface. And it's clear that we have not achieved disinfection. And then the plate on the far right is where we've actually followed that with the disinfection step. So you can see that, you know, significant, you know, further reduction in microbial contamination compared to just cleaning alone. So the bottom line here is that cleaning is important, but it isn't the same as disinfection. In fact, cleaning and disinfection work together. You know, they work hand in hand in order to successfully kill pathogens. And really, this mistake is getting into that cleaning process and why it's so important. So cleaning is so important for a couple different reasons. And the first goes back to that example of the plates that we showed. So, by removing this soil challenge, especially on, surfaces that are fairly heavily contaminated, this really makes the disinfection process that much easier. So we've actually found that sometimes cleaning just by itself can remove 99% of the pathogen load on the surface. So, really helping disinfection be effective by getting rid of those soils and really reducing that challenge. And then the second kind of aspect of that is we know that if there's a layer of dirt and debris on the surface, this can actually act as sort of a shield for pathogens, and it can actually block the disinfectant from being able to reach the pathogens properly. And so for that reason, it's that much more important just to make sure that we're removing that soil so that we can actually reach the pathogens, because if you can't reach them, it's very difficult to ensure effective disinfection. And so what cleaning might look like in lab animal facilities really depends on the setup of the facility. So if your facility is set up for wet cleaning, so if it's set up with drains and it's designed to be kind of like spraying a lot of water and chemical for the cleaning process, if you're dealing with a significant soil challenge, the cleaning may involve pre-cleaning with a separate detergent product or a disinfectant with detergency properties used at a higher dilution. And then this might be followed by the disinfection step. So you may have a pre-soak with a separate detergent to get rid of any of that major dirt and debris that might be on the surface. Whereas if you're just doing dry cleaning, most often you're not necessarily going to need a pre-soak step with a separate detergent. Often you can skip this and use a disinfectant, but it's important to use a disinfectant that is a one-step product. That's a one-step cleaner disinfectant. And I'll explain this just on the next slide. So when we talk about one-step cleaner disinfectants, we're talking about disinfectants that are formulated with surfactants, which is basically like saying they're formulated with detergents. And this allows them to stay active even if there's some residual soil, so some dirt residue on the surface. So obviously the cleaning step, we're gonna pre-clean any major soils from the surface, but even if there's some soil residue, this can make it a lot harder for the disinfectant to be effective if it doesn't have this package of surfactants built into the formulation. So whenever you're looking for a disinfectant, it's important to look at the language on the label to see if it's talking about being a one-step cleaner disinfectant. This is something that is very important, because if you're missing that, if it's not a one-step product, it may not be effective unless you're using a separate detergent product to pre-clean the surface. So choosing a one-step product really helps condense protocols and makes cleaning and disinfection that much faster and more convenient. So I'm just going to show a quick video, and really the purpose of this video is to show why it's so
cleaning
important
capabilities
to
of an
choose a
accelerated hydrogen
disinfectant
peroxide
with strong
one-step
cleaning
disinfectant
capabilities.
cleaner wipe versus a leading quad alcohol one-step disinfectant cleaner wipe. Hemostix reacts to the presence of blood through the detection of hemoglobin. The detection of hemoglobin will result in a positive reading. No detection of hemoglobin will result in a negative reading. Both tiles look clean, right? 1 drop of saline solution is added to the hemostix and then dragged across the clean tile. Accelerated hydrogen peroxide utilizes superior surfactants that results in effective cleaning to efficiently remove soils, ensuring you will kill the pathogens you are most concerned with.
Yeah, and so that really just shows how even on a surface that looks clean, you can get those residual soils. And so choosing a product with good cleaning capabilities, with a strong package of detergents built into the formulation, really helps ensure that you're going to be able to disinfect effectively. So our third mistake is choosing quality over quantity. So I'm just going to show you that these are basically two hypothetical disinfectant labels. And you can think of these as two labels for different disinfectant products. And on each one is showing the list of organisms that each disinfectant claims to kill. And so for this section, we're actually going to do a quick poll. And you can just, you can find the poll there where the chat is. And I'm going to ask you which product you would choose based on this list of claims. So if you wanted to choose a more effective product for your facility, and you're looking at these two labels, which one would you go with? So I'm just going to give you a couple seconds to do that, and then we'll talk about the results. Okay, so it may have been tempting to pick disinfectant A, and it's kind of a trick question in that sense because obviously it has a much longer list of organisms that is claiming to be effective against. But really what the whole point of this section really is trying to get at is the importance of choosing quality over quantity when looking at label claims to see what types of pathogens the disinfectant is going to be able to kill. So rather than looking at the total number of organisms on the label, we want to think about quality over quantity and what types of pathogens it's going to be effective against. So it's not realistic for disinfectants to be tested against every single pathogen that's out there because there's just too many possibilities. And so we need some type of system to think about, to basically group pathogens into categories and figure out based on this what a disinfectant can be expected to kill. So at the bottom, we have our envelope viruses, and these are generally considered to be the easiest type of pathogen to kill. So some examples you might be familiar with include influenza, coronaviruses are envelope viruses as well, and many other examples that cause common types of diseases. Moving up, we have our vegetative bacteria. So most bacteria are going to fall into this category, dealing with things like Staphylococcus, Pseudomonas, Salmonella. Moving up, we have our fungi, so our trichophytans, non-envelope viruses. So these are the harder to kill kind of viruses. And so they don't have this outer shell. And as a result, they're quite a bit tougher and more resistant to disinfection. So examples of these that you might be familiar with include, for instance, parvovirus, maybe murine norovirus, poliovirus is another example. And then mycobacteria at the top, this is the standard that disinfectants need to achieve in order to be considered intermediate level disinfectants. So we talk about avoiding the claims game, meaning rather than focusing on the number of organisms, looking at whether or not the product is effective against a wide range of different types of organisms, and that it's effective against harder to kill organisms. For example, if it has a claim against several non-envelope viruses, we can assume that that product's also going to be effective against much easier to kill envelope viruses. Same thing with mycobacteria. We can assume that it's very likely also going to be effective against vegetative bacteria, since that's significantly lower on the hierarchy and quite a bit easier to kill. So in terms of looking at disinfectant labels and choosing an effective product, there are a couple key things to look for. So we want to choose a hospital disinfectant, and that means it's going to have Staphylococcus and Pseudomonas, which are basically our surrogates for representing gram-positive and gram-negative bacteria. We want examples of those hard-to-kill non-envelope viruses. So it could be things like norovirus, parvovirus, to show that it's effective against not only easier-to-kill viruses, but also the harder-to-kill viruses. Fungi, so we might see trichophyton or microsporum. And then sometimes mycobacteria, depending on the requirements of particular facility SOPs. So if a tuberculocidal product is required, then you're going to want to be looking for that claim against mycobacteria. And just another point to note is organisms on facility-specific bioexclusion lists might also be added to the things to look for when evaluating a product. So going back to these two labels that I showed you earlier, so although disinfectant A has that much longer list of organisms, we'll break down why it actually might not be the better choice out of the two. So this has easy to kill viruses and vegetative bacteria, but it's missing a lot of those important organisms that we just listed. Disinfectant B, on the other hand, has quite a good balance, a good spread of different types of important organisms listed on that label. So we can see that it's a hospital disinfectant. It has claims against Staphylococcus and Pseudomonas. Those are gram-negative and gram-positive bacteria. It has that mycobacteria claim, as well as a couple examples of hard-to-kill viruses, non-envelope viruses, as well as fungi. So that's really going to be the more balanced option of the two. So now that we talked a little bit about how to choose a safe and effective product, we'll get into the other aspect, which is just as important, which is how the product is actually being applied to surfaces, because this can really make a big difference in terms of efficacy. So a main mistake is using the wrong application equipment when applying the disinfectant. So for dilution, we recommend automated dilution systems to eliminate user error from the process. And these help ensure that the correct amount of concentrate is being dispensed if you're using a concentrated product. As well as test strips can also be offered sometimes to confirm that that dilution is correct, just to really add that additional layer of confidence that the correct concentration is being used. In terms of how the product is actually being applied, we've seen facilities use a number of different methods, but we definitely support the use of foaming type applications for applying the disinfectant. And there are a few different reasons for this. So one is we know that foaming can reduce aerosolization of the chemical and minimize concerns around occupational health and even potentially animal health where the disinfectant's being applied. And this is compared to like a more traditional spray bottle. We also know that using a foaming applicator can improve our surface coverage and help liquids stay wet on the surfaces for longer periods of time. For wet cleaning, so there's a couple different options in terms of foaming applicators. So for wet cleaning, this might be a hose end foamer or a pump up foamer, and these can help quickly cover large surface areas throughout the facility. But for those smaller areas in dry cleaning applications, we might be looking at foaming trigger sprayers instead, or something that's better for those smaller surfaces. So just a quick note on, kind of going off that idea of applying the product. So one topic that we run into quite a bit is mopping. And so obviously string mops have been used in a lot of different industries for a number of years. But what we found with string mops is that there's the tendency for bacterial contamination to occur as a result of basically, as the mopping is taking place. If that mop is being placed back into the disinfectant solution, then there's that point of contamination. So we've seen a lot of facilities kind of choosing to move away from the traditional string mops for that reason. And an alternative to this is some sort of microfiber flat mop head like we're seeing here. So often facilities will apply the liquid directly to the floor and then use the flat microfiber mop head that can be removed after, or potentially saturating the microfiber mop head and then using it to apply the floor that way, just to reduce this issue of cross-contamination that we can see with string mops. So also on the note of cleaning materials, I think it's also important to talk about the actual substrate, the actual material that's being used for cleaning. And the example that this picture is showing is that we know that certain types of cleaning materials have the potential to interact with disinfectants in a negative way and interfere with the ability of the disinfectant to work properly. And a sort of famous example of this is this idea of quat binding. So a certain type of disinfectant a category called quats are known for the tendency to bind to certain types of cleaning material, specifically cotton in particular, I think also microfiber as well, and can bind to the material and will not be able to work properly as a result. And so we always advocate to make sure that you're working with your manufacturer to understand what pairings work well. So with your disinfectant, what are those materials that might be used? You know, is it microfiber? Is it potentially cotton, or is it maybe a pre-moistened wipe substrate like a melt-blown polypropylene disposable wipe material? So that's just something to keep in mind when making sure that disinfection is going to be effective. So our next mistake is spraying a surface and immediately wiping it dry. And this is something that we probably see quite a bit, especially during the pandemic, as we're seeing this increase in disinfection. But we'll talk about why it may lead to an ineffective process. And we'll start by just showing a quick clip here. And so my question is, you know, based on this, you know, do you think that the disinfection is going to be effective in this situation? And the answer to that question is no. And the reason for this is this idea of contact time. So as you can see, the product was being sprayed onto the surface, and then the surface is being instantly wiped dry. And that would be great if the disinfectant was fully effective instantly. But the reality is that all products have what's known as a contact time. And this is the length of time that the product needs to stay wet on the surface in order to be fully effective. And this information is found on the product label. So spraying it and wiping it right away is not going to be achieving that contact time. And it's important to, when you're looking for a disinfectant, choose a product with a rapid contact time, because, you know, not only is it going to make disinfection faster and more convenient, but it's easier to achieve compliance when you're using a product with a short contact time, because those longer contact times, like you'll see 10 minutes is fairly standard across the industry. If the product dries before that 10-minute contact time is reached, you're going to have to reapply it in order for it to be fully effective. And this was a study that was done looking at the ability of different disinfectants to actually achieve that contact time in a single application. So if the dark blue bar is significantly higher than the light bar, what that means is that it's drying quite a bit faster than when its contact time is being reached. So choosing a product with a short contact time that's able to stay wet on the surface is going to be really critical to disinfecting effectively. And then also ensuring that disinfection process allows for the contact time to be reached. So not spraying the surface and then immediately wiping the surface dry. So this is just a diagram of what that looks like. So on the left, we have a disinfectant was sprayed on the surface, and then after 10 seconds, the surface was wiped dry with gauze. And on the right, we have the exact same disinfectant. So nothing's different whatsoever about the chemical. The only difference is that it's being wiped and allowed to stay wet for that length of the contact time. And you can see a significantly greater reduction in microbial contamination just by having that contact time be achieved. And so that really just drives home the importance of not spraying a surface and then immediately wiping that surface dry. So our next mistake is on topping up bottles of diluted solution. And what this really comes down to is the importance of understanding shelf life of, you know, not only the solution that you buy of the disinfectant, but also of the solution once you dilute it, if you're using a concentrate or some other type of solution that you have to mix or prepare before you're using. So if you're using a concentrate, chances are that the diluted solution is going to have a shorter shelf life. And so by topping up bottles of the solution, this can result in new product being mixed with old product, and makes it difficult to keep track of the shelf life of that original solution. So we always recommend the use of workplace labels to document the shelf life on whatever secondary bottles are being used for the solution. And whenever possible, looking for a product with a longer shelf life once diluted, just to cut back on the amount of time that has to be spent doing this and make it much more convenient in the long run. So our last mistake is using ATP to compare different disinfectants. And I'm curious to know, and definitely feel free to jump in the chat. It'd be great to hear, you know, how many of you are familiar with ATP technology, how many of you have used ATP or are considering using ATP at your facility. But for those of you who might not be familiar with ATP, just a quick overview. Basically, ATP testing is a system that allows you to detect the presence of ATP on a surface. And ATP is a molecule that's produced by all sorts of different living things. It could be from microbial contamination, but it could also be from other sources of organic material. So it could be from body fluids, or we could also even be looking at contamination from food particles or any other organic material. So really what ATP testing gives you is a snapshot of the overall cleanliness of a surface rather than allowing to detect certain pathogens or even whether or not there are any pathogens on the surface. And so, we've seen ATP kind of gain popularity in a number of different industries. Certainly food service is a big one, but also in life sciences as well. And the caution here is avoiding using ATP to compare to different disinfectant chemistries or even to necessarily use this to choose a disinfectant. And I'll explain why just in a second. So we did a study a while back looking at pairing different disinfectants with ATP meters, basically asking the question, can disinfectants interfere with the readings of ATP meters and produce results that are not necessarily comparable? So basically, can you take the exact same level of contamination, use a disinfectant, different disinfectants, and get different readings based on interactions between the meter and the specific chemistry being used? And the answer to that question was yes. So we found that different chemistries can interact with specific ATP meter readings and produce different results as a result of this. And so our recommendation isn't that, there's anything wrong with ATP or not to use ATP as a rule, but really what it comes down to is understanding that it's not a reliable way to compare disinfectant chemistries based on these different interactions that they may have. And so whenever switching to a new disinfectant or implementing a new disinfectant in your facility, we always recommend working with the meter manufacturer and your disinfectant manufacturer to set a baseline for your facility. So to set pass-fail values that actually make sense based on the chemistry that you're using so that you don't get any misleading results. So it really is a balance of training, of setting that baseline, and whenever something happens, like you're switching chemistries, making sure that a new baseline values are set. So that takes us to the end, and I'll just a quick summary of the different mistakes that we covered. So the first one was failing to read disinfectant labels and safety data sheets. Then we moved on to underestimating the importance of cleaning and the overall cleaning and disinfection process. Choosing quantity over quality, sorry, as the mistake should be, when looking at claims on disinfectant labels, topping up bottles of diluted solution, immediately wiping that surface dry after it's being sprayed, and using ATP to compare different disinfectant chemistries. And so with that, we'll open it up to any questions that may have come in. And I'd like to thank you all so much for joining in. And I just want a note about Lighthouse Life Sciences. You can see the logo on the top there. So I'm really happy to share that Lighthouse is offering a free consultation for anyone tuning into the webinar today. So I think Laura's going to share their contact information in the chat, but if you want to reach out to Lighthouse, they'd be more than happy to get in touch with you about a free consultation for cleaning and disinfection within your facility.
Well, thank you, Matt. I did put the contact details in the chat there, so please feel free to reach out to Lighthouse Life Sciences. Now, we did get some interesting poll results in that I thought we could chat about very quickly. So going back to your mistakes that you referenced that people commonly make, one that we did ask the audience was, who is guilty of not reading labels? And no surprise here, I'm sure a lot of us are guilty of it, but 100% of the people who participated said, yes, they are guilty of not reading labels. So I'm sure you would reinforce that that's a very important practice that we really should be mindful of. Now, our next poll going back to Matt, when you were asking which disinfectant would you choose, we found 50% of the audience said, prior to you going into more detail, 50% of the audience said disinfectant A and 50% said disinfectant B. So also
an even split.
Exactly. Yes. So some interesting findings there. And we actually did just have a question come in from Devin. So relating to ATP, and that was another poll we put out to the audience as well, was do you currently use ATP? And we found 66% said yes, and 33% said no. Now, Devin is here asking for anyone available to help consult on establishing proper baselines for ATP testing. Apparently, Devin uses AHP and ATP, and they struggle to calculate baselines for your facility. So, Matt, any suggestions on who they should reach out to?
Yeah, I mean, we're definitely able to help with that on our end as much as possible. So basically, we'd work with you to basically set up that cleaning and disinfection protocol to get those baseline readings. And then it would be a combination of us working with you on that, as well as guidance from the meter manufacturer on setting up the limits. Like different meter manufacturers have different recommendations. Like some will say, to take a certain number of readings and then do an average. So there's different formulas that they might use, but we can definitely help support from the aspect of setting up the cleaning and disinfection protocols to actually do this process.
Well, that's great. And we did, of course, we put Lighthouse's contact details in the chat as well. So you are all free to reach out to Lighthouse as well for consultations. So it looks like that is all we have for questions, unless anybody wants to get anything in the last minute here. And we have, Devin just followed up and says, can I reach out by email? So Matt, what email would you suggest Devin contact us through?
Do we have an email in the chat there, or I can put in an email as well?
That would be great. How about you put an email in the chat? And it looks like that is it for today's webinar. So thank you to everybody who tuned in today. We really appreciate you joining us. And thank you, Matt, for such a great presentation. If you have any additional questions, please visit peroxyguard.com or feel free to reach out to us directly or book a consultation with Lighthouse. Again, their contact details are in the chat as well. You'll also be receiving a follow-up email with a link to the recording of today's webinar. So thank you again for joining us, and we hope to see you at our next webinar.